In the first 5 parts of this series, you learned some core concepts of clean architecture, and with this we have created bunch of folders in our project, and we also built the beautiful UI for our Instagram app. And if you are new to this channel and you have missed out the previous videos, so I would recommend go and check these videos out, that how we build this Instagram application UI. And with this we have added bunch of dependencies in our pubspec.yaml file. All of these dependencies will be used throughout the project. And now we will take start from this domain layer, which is innermost independent layer, and it's not going to hold any sort of concrete implementation, but there will goes our contracts and letter that will be implemented in data layer. And as you have seen in the thumbnail, that's the first video of authentication of users, so we are going to write only the entities and some methods and use case only for the user. And in the next video we will go for their implementation, which will be in the data layer, and then we will come down again to the presentation layer to call all of these use cases in the Cubit, and then dependency injection. And now what is dependency injection, everything will be clear to you in the upcoming videos. So now you don't have to worry about all of this, but first let's focus on this domain layer. So first there are entities or the business object, like what kind of data we're going to store in our Cloud Firestore database. First we are gonna have a user, then we will authenticate that user and all of that stuff. But what kind of data our user gonna have, like what kind of data our user entity is going to hold. So let's create a directory in these entities that will be directory of only user, and inside this user there will goes our dot file, which names will be user entity, and that user entity will going to be a class user entity open body, and there will goes all the data of the users. Like in other applications, the user basic data is like username, email and password and user ID, and that password will not going to store in our database. I will show you how this scenario will be, but first let's focus on this user entity. To check what kind of data our user gonna have, go to our main dot and change the sign in page to the main screen, and how to start the application. To go to our main screen and our profile page and check out what kind of data our user gonna have. So according to this we will create our business object in the user entity. So open the emulator and we have this single post. Go to the profile and our user gonna have his username, his name and the bio of the user, and total post, total followers, total following, and we're also gonna have followers and following list, because there will store the user IDs that like one user is actually following that user, and then we will increment in those total followers and following that will show up here, and that will be the total post. So let's click on this menu and go to edit profile. User gonna have his profile URL and name, username, and also remember that website, and we are gonna have this kind of data in our user entity. So let's go and create them. Go to the user entity and first we will create final string and make it nullable. That will be UID, like the user ID, and that will be unique for each of the user. And then a user gonna have string username, and also with this a user also gonna have final string only name and final string bio and also website, and with this email and also the profile URL and final list of followers, and again final list of following, and with this we are also gonna have total followers and total following. So final num total followers, and press Ctrl D to replicate it, total following. I put the type of followers num here hover on it and this will appear. It's an integer number and also the double. Like this will not going to throw any compile time error if it was integer or double. So it can be both just like this. So after this total following we will add a comment. I have added this comment and right after this we are gonna have another field that will be final string password and final string other UID. So why I did this? I did this because when we extend this user entity with the models in the upcoming videos, so we will access only these fields in the superclass and also in the final fields, but we are not going to use these two fields in our models because we are not going to store the password of the user in the database and also the other user ID. You only have to focus on these types because that will be stored in our Firestore database, but these two will not. Using this email and password from this user entity, we will only authenticate that user to the application, but that password will not going to store in the database and that other user ID will also not going to store in the Cloud Firestore database. So like I said, when we extend this user entity from the models, so we are not going to use these two fields and that will only be accessible when we call this user entity, and we will use this other UID for some other purposes that will be clear to you when we come to the real logic part. So for now you don't have to worry about this. Forget this, that there exists our other user ID. Just focus on these fields and also forgot this password because that will only be used when we authenticate the user and that's not going to store in our Cloud Firestore database. So that was it. Now there are some compile time errors when you click on a single field and press Alt Enter in the Android Studio, and if you are using VS Code you simply have to press Alt and dot. So this IntelliSense will appear and select the second one, create constructor for final fields and click enter. So this will create the constructor for all the final fields and you simply have to come at last and put a comma here to format them and press Ctrl Alt Shift L. So this will appear and press enter. So your code will be formatted, and also make sure to make these name parameters, so that will be good. And the next thing you have to do with your user entity, you simply have to extend this equatable. That equatable package is used for the value equality. Like if you don't use this equatable package, we will write all of this stuff to string hash code manually, but that equatable package give us the psychological air, as Stephen Covey said in 7 Habits of Highly Effective People. So after extending this user entity with equatable, there will come a compile time error in our user entity class. So again press Alt Enter and it says create one missing override. So press enter. So this will create a missing override here, and which is throwing an unimplemented error for now. So you simply have to remove this unimplemented error and put a list here and pass all of that data again here. Like copy all of that data from here and paste it here, but here we will not going to use this here. So you simply have to select this dot, and as I show you in the previous video, press Alt and J. So this will select all of this dot, and when you finish selecting all these, so press backspace, so this will remove them all. So you are done with the value equality also. So that was our user entity, and that all of the fields will going to store in the user Cloud Firestore database, and these two will not. That is the constructor for that and the value equality. And also if you want, you also can go at your own pace. And after this user entity, these use cases. The use cases are where our business logic will get executed. And as I said in the case of Cubit, if you remember in the first video, we are not going to write lots of logic in the Cubit, but that will delegate its work to the use case. The same will be in case of use case that will get the data from the repository. So let's create this repository methods. Everything will be clear to you one by one when we start doing them practically. So no worry about this. Let's create this repository and then I will show you how these use cases will be. The repository is going to have the Firebase repository because we are going to use Firebase as a backend. This will be an abstract class or our contract class, and its name will be Firebase repository. And again, remember, this is a contract class or an abstract class which will be later implemented in the data layer. So in this Firebase repository, we are going to have some methods of user, and that will be feature methods. Let's create a method that will be feature void. Its return type is void, mean nothing, a simple callback function. Its name will be sign in user, and this is going to take the user entity as a parameter, and that will be only user. Put semicolon here so our single sign in user method is also created. And like this, we are gonna have all of the methods of the user, like sign up user, create user, and update user, and get users, and all of them. So the second method will be feature void sign up user, and that will also going to accept the user entity as a parameter user. And while using these methods sign in and sign up user, from that user entity we are going to use only the email and password. That will be later clear to you when we start implementing their actual logic in the data sources. So with this, we are going to have another method that will be feature boolean. Its generic type is boolean. That will be is sign in, and put semicolon because this is not going to accept any parameter in the parentheses. That will only ensure that if the user is signed in or not. And the next method will be only feature void sign out to sign out the user, and this is also not going to accept any parameter. So this was the credential methods of our user. So put a comment here to make everything clear. That will be credential, and here now we will comment out user. There will be our user methods like create user in the Cloud Firestore database, and update the user, get single user, and all of that stuff. So first we will create the method of get the user. To get the user, that will not going to be feature because that will not be loaded, and that will be the live data. So we will use the type for the get user stream, which comes from the .core. That will be list of user entity, and that will be get users, and this will also accept user entity user. And with this, we are gonna have get single user. So press Ctrl D to replicate this because that's type will be same. We will change its name to get single user, and this is not going to hold the whole user entity, but that will only accept string UID, the ID of that user. And let's correct the spelling of this single just like this. And there will be another method of feature string get current UID just like this to get the current UID of the user, and then we will deal with this ID. And the two remaining methods are create the user in the database and also update the user. So for creating the user in the database, that will also be a feature, and generic type will be void. Its name will be create user, and it will also going to accept user entity because we will use all of these business object, and that will be stored in our Cloud Firestore database. That will also be user, and the last method is going to be feature void update user, and that will also accept the user entity. Its name will be only user. You can also put it user entity, but that's more clear to set the name to only the user. So that was some methods of our user. that will be later implemented in our data layer, and you will see this in action when the next video is uploaded. So if you have not subscribed to the channel yet, be sure to subscribe and hit the bell icon to make sure you get notified whenever the next video is uploaded, because we are going to write the complex logics in this application that will really help you to build maintainable applications so that you will get freelance clients or a job. Anyways, with this, let's go for the use cases. So in the use cases, let's create a directory here that will be Firebase use cases, and inside this let's create another directory. Its name will be user, because there will be all the use cases of the user. And on the other hand, if you look at these methods in the Firebase repositories, these are the use cases, like to sign in the user, sign up user, check if the user is signed in, sign out the user, get user, and all of that. Because for each of the method we will create a separate use case, and later this will be called in the Cubit and its implementation will be in the data layer. Like this, these all layers are interdependently connected to each other. So let's create the files for them. That will be sign in user, use case, and sign up user, use case, and just like this create for all of them together. So let's create the files for them. That will be sign. So I have created all of the user use cases in here, and that each file is going to hold a class, and here we will call a specific method according to this file name from this Firebase repository. So go to the create user first, and there will be a simple class, and that's the file of create user. So we will name this class to create user use case and open body, and here we will take the instance of our Firebase repository. That will be Firebase repository and only the repository, and also alt enter and create the constructor for this field and make this name parameters and also make it required. And there will be a single method. Its type will be first the type of the creating user was future void, so we will copy this from here, go here, paste it right here, and its name will be only call. This will accept user entity as the create user method does, and user and open body, and there will comes return repository dot create user, and this will accept this user from here. So all of the use cases will going to be just like this. A simple class according to their name will accept the Firebase repository, and a simple call method in all of these use cases and will return the particular method from the repository, and that later the use cases will be used in the Cubit and then our pages, and their backend will be inside this data layer. Like this Firebase repository will be implemented here, and all the real implementations will be inside the data sources. So like this, these are only use cases of that create user, and that create user will be implemented completely in the data source. In the next video, you will see this in action, how we will write the logic for all of these methods. So copy this class from here and go to the second file and paste it right here, and make sure to import this Firebase repository and only change the name of this class. Select this and press Alt J to select the same constructor name, and change this create user to get current UID use case, and that is not going to accept any parameters as we have in the Firebase repository. This method is not accepting any parameters, so we will leave it empty just like this. Its return type is string, and you can see there comes an error. The value type of future void can't be returned from the method call because it has return type of future string. So we have to return the method which has the return type of future string, and that is our get current UID, so the error will be gone. Just like this, you have to do this stuff for all of the use cases copy and paste it for git single user and import this Firebase repository. Change the name of this use case, that will be git single user use case, and its return type will be not future, that will be this time stream list of user entity, and this call is going to accept a string UID because if you look at again in the Firebase repository, our git single user accept a single UID, so that will be Firebase repository dot git single user, and the error will be gone. Again copy this and go to git user, paste it right here, change the name git single user to the git all users or only git users, import the library and its return type will be the same, import the user entity, and this is going to accept only the user entity instead of UID, that will be git users and user entity, and that was it. Go to is sign in. Before, let's copy this, change the name of it, and you can also skip this part if you can do it by your own. Its name will be is sign in import, and its return type is feature boolean, and it accept nothing here. From the repository we will call is sign in, remove this user entity also from here, and go to the sign in user. First copy this, paste it right here. First you have to do change name sign in user use case, import the Firebase repository. This return type will be future void, and this is going to call sign in user, and this call will also accept user entity, and just like this. And go to the sign out use case, change its name sign out use case, remove this user entity from here, sign out again, copy this, go to sign up use case and make sure to change its name, and this will accept the user entity, and also the user entity here, and sign up user, and also make sure to import this Firebase repository and copy this from here. Go to update user use case, paste it right here and change its name to update user use case, and everything will remain same because the update user accept also the user entity, and make correct the spelling of this update just like this. So we have created the user entity for our user. That data will be stored in our Cloud Firestore database, and that will not be stored in the DB as commented here, and that is for value equality. We create a contract class here that will later be implemented in the data layer. Here in the repository implementation you will see this in action in the next video, and we have created the use cases for all of these methods that will goes in the Cubit, and just like this that flow will work. And also if you want, you also can go at your own pace, and you also can get this code from the GitHub. So I hope this video was helpful. If so, show some love in the comment section, and also let me know if something is not clear to you. And with this, be sure to subscribe and hit the bell icon to make sure you get notified whenever the next video is uploaded. For now, goodbye, and I will see you in the next video.